here we go. Maybe if I go to the very front, like when you see quadratic functions, like quadratic, you want to be thinking parabola, like that's the shape of the graph. It's like a horseshoe, but it keeps on opening up indefinitely, right? So it's not a U, it's kind of like, so it's either going to face this way, it's going to be pointing, the legs are going to be pointing up, or the legs are going to be pointing down. So that's like a very key component. And the general form of equation is going to look like this. Y is equal to ax squared plus bx plus c. That's the general form of a quadratic equation. Granted, b could be 0, so this whole thing, the x component, could be like missing, could be non-present, right? C could be 0, so it may be that sometimes you don't have the b and the c, but you most definitely need the x squared component for you to have a quadratic. So this is just to give you like kind of like the cover page. You're gonna see it multiple times, so I just thought I'd put it up there. All right, let's dive in here. So some fill in the blank. A linear function has the equation y is equal to ax plus b. Good morning. Where a is the leading, it's called the leading coefficient. And I apologize, it's a little tight here. Oh, you can't see that, can you? There you go. It's called the leading coefficient. That's what a is in our equation. And it's linear, right? You should remember last year you spent a lot of time on linear equations, or last semester, I don't know what it was for you in the intro course. The constant b is the what we call the y-intercept. And if I will review some of these concepts again, but it's just right now just fill in. It produces a straight line since the highest power of x is 1. Okay, the exponent of the highest power is what's going to give it away, what kind of function it is overall. The equation has a degree of 1 for that reason. So if the highest power is 1 for x or any variable, then the degree is 1. Note, y is equal to ax plus b can also be written as, this is probably how you remember it, mx plus b, where m was the slope. Do you remember the slope vaguely? It tells you how steep the line is. Anyways, but from now on, we're not going to necessarily refer to it as m. M is the slope and b is the constant. It's just a number. Now let's shift gears to quadratic. Quadratic function is the equation y equals ax squared plus bx plus c, where a cannot be 0. Okay, a cannot be 0, or else it ceases to be a quadratic. B and C may be 0. That could be gone, but not A. Where A is still the leading coefficient. Leading coefficient. Think of it as the leading number, the number that's in front of the x squared term. And the constant C is the y-intercept still. It produces a parabola. That's the name of the graph, of the shape of the graph. It's a parabola. Since the highest power of x is 2, the equation has a degree of 2. A quadratic function will always produce a parabola. It points either up or down and expands sideways indefinitely. Okay, so you can have it again like this, up or down, arrowheads because it keeps going, and that's what you get. Okay, it can't be sideways, just up or down. So state whether the graph is one of the following: constant, linear, quadratic, or not applicable. Okay, so this one points up, it opens up indefinitely, so this is a quadratic. This one, we actually don't know what this is. We're not told enough information. If this were to point back up, we would say it's a parabola, but this one is NA, or not applicable. This one is a quadratic, points down. This one is, you should all know this one, this is a linear. This is actually not a linear, it's a constant function. Example would be y is equal to 2. If y is equal to 2, that's just a horizontal flat line. Slope is 0. Right? This one is NA as well. If it's sideways, it's not a parabola. Okay. This one here you will explore next year. This one right here and other ones. Okay. Let's keep going. Okay, so we're going to look at every single equation and fill out the rest here. For this one over here, you look for any variable. In this case, it's y and x. X, the greatest power is 1, so the degree of this whole thing is 1. Type of function, it would be linear. The leading coefficient, right, is in front of the highest power of the variable, so it's 1, plus 1, I may add, right? Plus 1. The constant is just that 7. The number that has no variable attached to it is what we consider our constant. I'm going to zoom into that a little bit, folks. Help you out. Y, the degree is actually 0 if it's just y15. X to the power of 0, like if you wanted to, you could go x to the power of 0, that's just 1. Anything to the power of 0 is 1. That's where that comes from. And so this is a constant function. Leading coefficient is NA. There is no variable. And the constant is just 15. Over here, you look at your variables, you see the x squared, so you know it's a degree of 2. Type of function is quadratic. Leading coefficient is in front of the x squared term, so it's -3. Okay, so you take the sign and everything with it. And the constant is -5. Morning. This one, the degree is 3. Okay. The degree of this one is 3. You don't know the name yet, but it doesn't hurt. Cubic. It's actually a cubic function. You'll learn about that next year. The leading coefficient is just 1. Constant is 0. Okay. If there is nothing there, the constant is actually 0. This one, we're just going to go NA because it's 1 over x, right? It's the same thing as 1 over x. We're not going to explore that. So just go NA everywhere. We're not going to talk about that. Do you remember foiling? You remember FOIL? What happens when you FOIL this out? What do you think you're gonna what kind of term is gonna be in there? Practice that. Can you FOIL that out, like multiply it out and see what you get? Use a space underneath. If you get it wrong, big deal. Let's see how you did. Whenever you have a bunch of things multiplying, just multiply 2 brackets or terms at a time. Okay, so I will leave the 6 out for now, right, and just kind of worry about these 2 brackets. So it's x times x is x squared. X times positive 3 is plus 3x. And you go negative 5 times x is negative 5x. Negative 5 times 3 is negative 15. Clean that up a little bit. Combine like terms, like the middle here is negative 2x minus 15. Oops. There. And then you multiply the 6 throughout the thing. So it's 6x squared minus 12x. And that's 90, right? 6 times 15 would be negative 90. So that's where factoring comes in, right? Like you would normally be given this, take out the 6, and then come up with your. We won't be factoring that. That's the good news. We don't factor anymore. We use our calculator. But I would expect you to expand it out, right? That I would expect you from time to time to perform this. And don't worry so much right now. Like we're gonna do more. This is kind of just an aside. So technically, my equation, or f of x, don't let that throw you off. I want you to be okay with that. That's the same thing as saying y is equal to. This is written in function notation. So let's rewrite this. I'm just going to say, technically, this thing can now be written as f of x is equal to 6x squared minus 12x minus 90, okay? So the degree of this is 2 because of that highest power there. Therefore, I know it's a quadratic. The graph is going to be a parabola. Okay. The leading coefficient is actually 6. And my constant is negative 90. Okay. And if what I would like, maybe I'm going to do that just to introduce it to you already, right? So the 6 is what we would consider A. The negative 12 is what we would consider B. And C is just that negative 90. It's just the numbers. It's not the variables, okay? Sometimes when I ask what is A, some students write down 6x squared, and it's not right. It's just the 6, right? So the letters refer to the numbers only. All right. Let's keep going. A lot of review. Some review, some is just getting you warmed up to the concepts, okay? All right. So when it comes to the quadratic equations, just like in linear, you had your standard, you had your slope point form, slope intercept form. Remember those forms of the equation? Same with the quadratic. The general is the one I already introduced you to, but write it down anyways. It doesn't hurt to have them all in one place. One thing that I need you to be aware of is it's not saying that it's always going to be plus, okay? Some students think, oh, because it's plus, always going to be plus. No, it could be a negative in there, but that's in general what it looks like. The descriptive or vertex form, this is going to be a bit clearer later on. It looks like this. HK, what's up with that? Right? We'll learn more. We'll do a deep dive later on these. Right now, I just want you to know what they look like. And then the factored form, you're probably going to recognize it, right? You would have your leading coefficient up front, and it would be x plus r, x minus r. Oops. So that's the factored form. I think what I want you to remember here is whenever you have something that has brackets in it, it's not general. Okay, that's what I want you to remember. If it has brackets, you're like, okay, it's one of these two. Because general gives us some information, and these two will give us other pieces. So what this gives us, right, it gives us the y-intercept. When you look at a general form, if you just see that number, it's going to be 0, C. Okay? So whatever this is, that last constant, that's what our y-intercept is. Okay, so that's what the general form gives us. This middle one gives us the vertex. Vertex is, I'm going to explain that in a bit. For now, just write that down. But the middle one gives us the vertex, and this is what it does. I'm going to use a red pen for this one. I would recommend you do something with a different color here. You take H, but you change the sign of it when you put it out here. Okay, you change the sign. That's what that's why you put a negative in front when you bring it out. And then just K as is. Okay, and I forgot to, this is technically the vertex like that, dot, dot, okay? The vertex is that. That would be the coordinates. That would be the coordinates of the vertex themselves. And then the last one gives us the x-intercepts. I would say x-intercepts or x-intercept. It could vary. So in this case, you also need to make sure it's going to be, the first is going to be negative r. I'm going to use a negative like that, 0. And the second one is going to be, oh, sorry guys. Can you, before you copy, can you change this to, this is supposed to be r and this is supposed to be s. Okay. So it's going to be negative s 0 like that. So I'll make that note here. Note the negative, right, changes the sign. Okay, I would make a note of that. And I will come back to this later. Okay, here are the good news about this course. Okay, here, regardless of which one you're given, we simply type them into our calculator, right? Simply type them into our calculator and use second trace to find additional information about that parabola. So that's the beauty of this course. No matter how ugly the equation is, you type it in, let the calculator do the heavy lifting for you. Okay, you just need to, you're gonna have to know how to tweak it sometimes, your screen. I'm gonna teach you how to do that. So never panic, just type it in. Okay. Most of the time you'll be given an equation in general form. We'll start the unit focusing on the general and then we'll add the other forms gradually. However, I can give them to you right off the bat, right as I do general, and you just type it into your calculator and do everything that I'm about to show you. There are some properties of the resulting graph that can be extracted by simply looking at the equation. Okay, so if this is the general form, right, this is general, remember. We can tell which way it's going to open, guys. And this is very good. You need to be able to predict what it's going to look like to make your jobs easier when you use the calculator. So the direction of the opening of the parabola can be determined by the sign of the leading coefficient A. So if A is positive, right, then we know for a fact that your parabola will look like this. If A is negative, we know for a fact that it's going to be pointing down. That's it. So just by looking at the equation, you can tell already what's going to happen. Okay. Next, the width of the parabola. This is not so crucial to find answers, but to adjust your window later on your calculator. The leading coefficient determines the direction of opening, right? And the width. Okay, so it's direction and width, really what it tells us. So you want to focus on these three here. Some of you like visual, so if the leading coefficient is anything between 0 and 1, you'll have a wide parabola. And so, but what I mean by that is it's going to be like, when you look at the screen, it's going to look like this. It's going to take a long time to kind of open up, or it's going to take a long time to open for you to realize that this is actually opening downwards. So it's a wider parabola. If you look at the same screen, and I told you that if you realize A is exactly equal to 1, that's what we consider a normal width. So it kind of looks like the traditional parabola, just like this. And I just basically want you to know what to expect, right? If A would be anything greater than 1, you actually have a very narrow parabola. Okay, so let's shift it over to the side here, but it's going to go like this. Okay, it's going to be the legs are going to be closer together, or we could have it down here. Notice that the sign doesn't matter here. The sign, it doesn't matter. It's just the actual value. Let's keep going. And I know I'm bombarding you a lot, and later on I'm going to draw on this, and with some practicing, we'll wrap our heads around it. The y-intercept, a quadratic function will always have one y-intercept. Maybe that's worth highlighting. There's always one y-intercept. When the equation is in general form, the y-intercept will be 0c because it is the point on the y-axis. Notice if the equation or function has brackets on the right-hand side, it is not in general form. I'm going to use a different color for this one. If there are brackets, it is not in general form. How's that? Okay. If you see brackets at all, it's not in general form. Okay. How about this? I'll give you an example. I see students making this mistake all the time. So let's say I give you f of x is negative 5, x minus 4 squared plus 7. And I ask students, hey, what's the y-intercept? A lot of students think, oh, it's the constant here because you keep on telling us that it's that last number that's the y-intercept. Students go back to the general form. Okay, so students might say y is equal to 7, and this is wrong. Okay, this is an error. Y function is not in general form. Okay, that's what I'm trying to say here. So if you see brackets, okay, if you see these brackets here, maybe I should use orange because that's what I used for brackets, right? If you see brackets, it is not in general form. So maybe right now won't make sense to you, but later when you flip through your notes after having done the unit, this might be a nice reminder. Okay. Okay, so let me see here. I think I'm going to pause on these charts here a bit, and I'm just going to keep going on page 5 and then come back to this, okay? Some other properties. Page 5. Here's the probably one of the most important concepts is the vertex. I'm going to actually highlight that on page 5. It would be the coordinates x and y of the point, right? It's the point where the parabola changes direction. It can be the highest, right? It could be the highest point, which is a maximum, or it could be the lowest point. Then it would be a minimum. So the vertex could be either one. And this is important here. To determine the coordinates of the vertex, we use second trace min or second trace max. This is going to make sense later on, okay? I will highlight that. You know what? I'll warm you up to your calculator already. So whenever you see those square brackets, I usually mean buttons that you press. So grab your calculator, and second is right up here on the corner. So you press second, trace is way up here next to graph. This is trace right here. If you press second and then trace, these are the functions we're going to use a lot. So I'll do it one more time. Second mode, you quit back to the home screen. That's how you always exit whatever you're in. Second mode quits, right? Quits to the main screen. So you want to go second trace. We're going to use 1 to 5 in this course, and you're going to use that next year as well. So remember, second trace, you calculate anything you want off of a graph. Okay? All right, so I'm going to go second mode to quit back to, so some students get stuck and they're like, I don't know how to get out of this, whatever I'm in. Second mode, you quit and you go back to the home screen. So that's what I mean with this, or min or max. So if you notice a parabola, it looks like this. So watch what I'm doing here. I'm just going to graph it. It doesn't have to be exactly like I have it. Just try to make it look like this. So this would be a case where you look at the equation, you're like, okay, A is positive. I know it's going to be pointing up. Or you could have an instance where, let's make it just stay here under the x-axis. You know, in this instance, A is negative, okay? That piece we know. So the vertex in this particular case, look at this. If you look from left to right, you come down, right? There's a point where it changes direction. It's right at we call it either the valley or the top of the hill, right? In this case, this would be the vertex. You would use second trace min because it's the lowest point to find vertex. Okay, and remember, it's a xy coordinate to get there. And in this case, the vertex, if you go from left to right, that's how you always read a graph, from left to right. Same if it's a linear. This one kind of looks wonky, but I hope you know that one is the vertex right there. There's only one, okay, xy. And to find this one, we would use second trace max, because it's the highest point, it's the maximum, okay? It's the highest point in this graph. It's the turning point. So that's important. The coordinates of the vertex provides us with 2 additional pieces of information. Okay? So the vertex will give us this, and the vertex will also give us that. just by looking at those coordinates, we know two things about the graph that I will refer to. It gives us the equation. It's important to notice, right? It's the equation of the axis of symmetry. And there's the equation of the max or min. Can you circle or underline equation? Both of them are equations. So the equation of the axis of symmetry, I use AOS often. It's a vertical line that cuts the parabola in identical halves and goes through the vertex. Okay, so in this case, it would be, if this is your vertex right here, visually the axis of symmetry goes right through it like that. And it's a vertical line, it goes up and down. And if you could look up here, these are the coordinates of the vertex, correct? And the x value here is what I use to write the equation of this line is x equals to 2. X equals to 2. So I basically used the x value of the vertex to come up with the axis of symmetry. Can I just next to this say this is the AOS in brackets? So the axis of symmetry is that. Let's go and find the axis of symmetry on this graph over here. Well, the vertex is right there. So we're just going to make a vertical line. That goes up and down like this, cuts right through the vertex. In this case, the axis of symmetry would be x is equal to negative 2.3, right? And put axis of symmetry in brackets like that. This is probably the most frequent. I do ask often for the axis of symmetry. So just look at the x value. Do you want to do the same here? Okay, that's how I got it. So if you know the vertex, you know your axis of symmetry. Then there's the equation of either the min or max. They don't both exist at the same time. In this case, there would be a max here. So it's actually a horizontal equation, a horizontal line. It's the equation of a horizontal line. Sorry, I should have clarified there. It also goes through the vertex. Same with the other one. Go to your vertex and just make sure you cut right through it like that. So this would be the line y is equal to 3. And this one here would be the line y is equal to negative 3.5. And yeah, write down that this would be a max right here. And this would be a min. You can't have them both. It's either or. So some mistakes, students say, hey, the max is 3. It's an equation. It has to be y equals to 3 if you want full marks. Okay. So again, technically, can I just add something? This graph, technically, there's no word problem associated with it, so it would keep going indefinitely, right? Should be arrowheads on the legs. there should be arrowheads on the X and Y axis. And you're like, why doesn't he just, oops, sorry, this is not, why doesn't he just do that with his computer, right? Because I'm going to ask you the graph by hand, so you need to make sure those details you think of, and I'll remind you. So label your X and your Y axis, put arrowheads everywhere where there have to be, and so forth. Okay. Let's go to this part. Questions or point number 7 on page 6. So I'm just going through all the properties that a parabola can present. Okay. The x-intercepts. This is also very important. The vertex and the intercepts are the most important pieces for us, especially when we have to graph it. Quadratic functions can have up to, watch this part is interesting, not like your linear equations last year. They can have up to 2 x-intercepts. And I want to talk about that note, right? The degree of the function tells you how many x-intercepts are possible. Okay. When you looked at linear, it has a degree of 1 x-intercept possible. Quadratic, degree of 2 possible. Cubic, 3 possible x-intercepts. So keep that in mind for next year. Sure, Mr. Dirksen, I will think about it all summer long, right? So there's either no x-intercepts, 1 x-intercept, or 2 x-intercepts. So no x-intercepts is when this happens. Okay, so imagine this your graph. So it can either be like this, or it could be like this, right? You can tell that no matter what happens, it will never cross the x-axis. It will never cross the x-axis. Exactly 1 x-intercept is when make a dot right on the x-axis like that. And so I'm going to go off of that with my legs. Watch, like this. I'm going to go off of that. Because remember, a parabola is actually symmetric. Okay? And the vertex is what cuts it in half. It's the line of symmetry, if you want to think of it that way. Grade 9. I don't know if you remember that. For COVID, maybe something happened there. It didn't get covered. Then the other one is here. It'd be pointing down. So I always talk about both scenarios, either pointing up or down. But there you can tell it's only going to cross it once. And then you have the case where it crosses it 2 times. So I'm going to have a graph going like this. And you will focus on the x-intercepts here. And then you have one going like this. Oh, sorry. It's supposed to be going up. Sorry, guys. Right? There you have 2 x-intercepts as well. And so I will give you some explanations here. So you either have vertex above x-axis and points up. In that case, A is positive. Oh, you know what? I never added this to my notes before, but how do you know a vertex is above the x-axis? Well, here, vertex, this would be an example. It's where you don't care about the x value. You don't care about it. But the y value has to be positive. Like if the y value of the vertex is positive, that means that you're going to be above the x-axis. On the other hand, here, vertex below x-axis. What I mean by that is that your y value of the vertex will be negative and points down. A is negative. So those are both instances where it's just not going to happen. This one here, vertex is on the x-axis. How do you know the vertex is on the x-axis? How would you know by looking at it? Well, x, I don't care. What would this have to be dancing on the right on the x-axis? It'd have to be 0, right? And you know without a doubt that it's going to be on the x-axis. Does it matter which way it's pointing? It wouldn't matter, right? If this is on the x-axis, whether it points up or down, it doesn't matter. Direction of opening is irrelevant. Two x-intercepts. It's basically a little, I'm just going to change a little something from this statement. Instead of vertex is above x-axis, I'm going to say below. Okay? So one is where vertex below x-axis. So that means that the vertex would be x, negative y, and points up. So A is positive. It's one instance. Or vertex above x-axis. So that means that vertex would look like this. And points down. A is negative. Or opens down. It doesn't matter. You can use take a little break. 2 minutes. Too much talking, right? You may not be. Let's get back on the horse. You're like, I've never been on a horse. Never. Why would I do that, right? Anyways. Domain and range. I don't know if it brings back bad memories or good memories, but you need to know your domain and range. Okay. I'll try my best to help you out here. So right now, this one right here, I need you to understand that this is only for, the domain and range is for non-contextual graphs. Say what? Okay. No word problems. This will change once you have word problems, okay? So just warning you. Domain refers to all permissible x values, right? So you want to be thinking, I don't know if this helps in your study sheet, right? Domain, you're looking for what are the x values allowed, okay? And so in this case, because the parabola opens up indefinitely to the side, it's going to be x is part of all the real numbers. So basically it could be anything, negative or positive, decimal, fraction, you name it. Anything goes. Okay, that's what this is reading. X belongs to the real numbers. Okay, X can be anything in the real number category. Interval notation So there's set notation and interval notation. I'm sure you learned that last year. So interval would be negative infinity to positive infinity. And because you cannot contain infinity, notice that there are round brackets, right? Round brackets. We're going to review later on when we have squared brackets, okay? And if you do set notation, like, I don't know, I call them the squiggly brackets. You can call it whatever you want. So that's the main difference between the two. I don't know if your teachers emphasized the brackets last year, but in applied, you have to include brackets. Okay, you can't just leave it open. That's very important. Range refers to all permissible y values. So when it comes to range, it's the y values, right? The y values you're after. So I'm going to use purple and orange. Right? So domain, I'm going to use purple for that one, or pink. I don't know. I always have that argument with my wife, like, it's pink, it's purple. Whatever. Whatever color you think it is, use it, right? And then for range, we refer to the y variables that are acceptable. And notice this, okay? Here, we know when you look at this graph, you don't know what the equation is, but one thing you know for sure is that A is what? Positive, right? You look at this graph, you don't know what the equation looks like, but you know for sure that it had to start with a negative A value, okay? That's for sure. And so whether it points up or down, it determines how my range is going to be stated. The domain is the same. The domain is either this in set notation, this in interval notation. I don't care which one you give me, but you need to be able to read it either way. You can answer in the format you prefer, but you need to be able to read it either way. But for range, it's a little different. Okay. So this is range, just so you know. Okay. For set notation, I would write it like this. Y has to be greater than or equal to whatever the y value of the vertex is. I hope you can read that. I want the graphs on there. Okay. But y is greater than the y value of the vertex. Interval notation, it would be like this. And obviously later we'll have numbers there. Y value of vertex, right? You start with that, comma. Watch this. If you look at the graph, you start here, that's the lowest, but then you go to, like, this continues to go up indefinitely. So this would be infinity here. You have to have a round bracket here. Okay, square bracket, round bracket. When it comes to the one where it's pointing down, in general, sorry guys, you want to make sure I get this right. It's R like this. Like you put an R in front normally, okay? And for the one that's pointing down, it's slightly different. Y is what? If you look at this, Y is less than. This graph only exists if Y is less than or equal to the Y value of vertex. And this is practice and maybe adding this to your study sheet. And interval notation, you actually go and this, oh sorry, I started it wrong, guys. It's always smallest first, largest second, always when you do interval. So this is being negative infinity all the way to the y value of vertex. And there's a round bracket here. There's a square bracket here. Very important. Get that right. So the way you read it is always from the bottom up. Your range actually to read it from bottom. So you come from negative infinity all the way to the top value, right? So that's what goes in here. Do I need to add something here? Hold on. Go up to these graphs. I'm just going to say this is x, y right? Y of vertex. And here you have x, y of vertex. These are coordinates, right? So coordinates always have round brackets around. So here are some common mistakes that I see students make. So they'll try to, so example, let's say you have a graph that looks like this. And this is -5, 3. And I ask students, hey, give me the domain and range. Like that. And the domain is the easiest if there's no word problem. It'll just be like this. Squiggly brackets. Or you can just say x values go from negative infinity to positive infinity. Like that. So that one is the easiest one to do. The range is where we have a bit of trouble. So this is a case where a is pointing down. Or a is negative, sorry. So this is pointing down. So for set notation, y would have to be what? Well, I look at this, and you look at the y value, it's 3, right? So y would have to be less than or equal to 3 here. If y is anything bigger than 3, this graph no longer exists, right? You can look either way, you're not going to see it. Or what about this one? This is what I see a lot. Don't copy this. I'll put an error next to it. Some students go like this. And this is wrong. And you know why you know it's wrong? The smallest always comes first, and then the largest number second. Negative infinity is smaller than positive 3. Okay, so this would be an error. Okay. So you got to go negative infinity to positive. Oh, this would be wrong too, right? This has to be a round bracket and square bracket there. Okay. Smallest, largest. Okay. That's how it always goes, and that's how you can check whether or not you get it right. Because some students, they know the two that they're supposed to put in, the order just doesn't line up. So make sure you get that right. Okay, so 10 minutes left, huh? I was gonna do the calculator thing, but I'm not. I'm not gonna do the calculator. So what I'm gonna ask you to do for homework is page 8. It's the domain and range. So put down homework at the top of page 8. And I'm going to go back. I skipped that page earlier. Page 4. If you go to page 4, I'm also going to ask you to do that. So you can put homework here. And if you're like me, it's like I don't like stuff all over the place. Maybe you just write it down somewhere on this page, right at the bottom of 4. You just say homework. page 4 and page 8. Okay. But this one I want to start with you. Page 4, I'm going to get you started with at least one so you kind of know what I'm expecting there. I'll post the key, but I think it's fair to say that you might have a hard time for some of them. And that's okay. If there's some you come across like I don't know how to do them, I'm okay. But just try as many as you can. Okay. Page 4, this first question here. Is this in general form? No brackets, right? It's in general form. It just doesn't have the B and the C part, right? The BXC, it's not there. There's 0. It's in general form. I'll write it down. General. Opening. Which way is it opening? I look at the -2, so I will say it's down because A is negative, right? You tell me why it is. The width, you write on page 3 there are your 3 types of widths you can have. And actually, this one is a narrow. Why is that? Because A itself is greater than 1. And you're like, Mr. Dixon, A is -2. Why are you saying it's greater than 1? You got to strip the sign from it, right? You got to take the sign away and just focus on the numerical value. So if you look at 2, just the 2 here, A is greater than that, so it will be a narrow curve. No matter what, it's going to be pointing down, but it'll be narrow compared to the normal one. Y-intercept, it's 0C, because it's in general form. You know the y-intercept is 0C. Can you see, you know what C is in this case? It is 0. So your y-intercept is 0, 0. Anybody know what we call 0, 0? It's called the origin, right? It's right at the center of your graph, the x and y. It's right at the center. So it's interesting, but it's all right. So this is in general form. This is in general form. General form, not general. So I'll just say try your best on this one. I'll show you tomorrow. We will use the calculators tomorrow. Sometimes I get to it and then I assign this one. So you can put a star here. You can do the opening and the width. You can definitely do that. You just can't do the y-intercept maybe. If you think about it, you could. So anything that has brackets in it, you don't have to worry about it. Okay? Thank you guys. That's it for today. You did very well.